Okay, it's 12:05. We'll get started now. If anyone comes late, that'll be okay. At the end of this, I'll post a really quick, like 1 or 2 pager note, which is basically just going to be a comprehensive summary of everything I'm about to say. So no worries if people come late. Although I don't know why I'm telling you, because all of you are here on time. But the point is, if you need to dip out at any point, don't worry. There's going to be a comprehensive sheet that just basically covers everything I've just said. Okay, so this is an introduction to Git. So okay, so I already posted this link in the Zoom chat, but basically if you want to type this link in your URL in a browser, it'll take you to a website where you can download Git. You don't need to download it for this workshop. You can follow, if you want to follow along, go ahead. I'm just going to be making really easy coding examples. I'm just going to be showing you how to commit changes, how to also work in a team environment using Git, as well as how to just basically put your project all together in the context of a team. So basically you can download this now if you want to follow along, or download it later. I'll also post this slide later. So basically this is just to let you know that Git is something that you can and should download at some point. So just a really brief introduction to what Git is and why it's something that's really useful to learn. So in the context of coding, so if you imagine so what Git specifically is, it's a distributed version control system. So what does that mean? It means that you can easily control different versions of your project. And since it's in the context of a distributed system, it means that when that system's necessarily distributed, it means that everyone who necessarily has that project will have some version of that project. And it's distributed, that is to say, it's also non-centralized. So why is this really important? Because if you imagine the context of collaborating when you're coding, if we want to talk about things like the context of collaborating on a group project that you're used to at school, maybe you're all maybe you're all collaborating on something say a PowerPoint presentation or an essay or a document. If you go to Google Drive, you can all easily just simply work on it easily. You just have one person type up one page, you have another person type up another page, and because of how Google Drive's formatted, it just auto saves and everything just automatically works out. We can't do that with coding. The reason why we cannot do that with coding is because when it comes to the context of coding, everyone necessarily has different environments. Not to mention, when you're creating software, you need some sort of hardware to actually run that software locally in order for in order to create something that's actually powerful and useful to a user. So maybe you're trying to do things like create a web app, maybe you're trying to create a mobile app, maybe you're trying to do things like create a desktop app if you're using Electron or something. But the point is, when it comes to coding, in order to actually make that code something, in order to actually run that code, in order to actually test it out, in order to ensure that it is functional, you need some sort of machine that's necessarily going to help you out. So that's why it's hard to do in the context of a browser. Sure, we have things like Replit, but if you want to run something that's really powerful, if you want to say I don't know, use an emulator to run Android, or if you want to test out mobile apps, you need to do it on a local machine. So the question then becomes, in the context of a team environment, let's say you have a team that's distributed among different members. So let's say one member is working on the client side, another person's working on the server side. The question is, how do we get these different components to all work together? And how do we just basically get these different components to come together in the context of creating one single project? So this is where Git comes into play. Git basically just helps us manage these different versions of code that we have within a project, and it just simply allows us to put it all together as a distributed version control system. So what then is GitHub? To be clear, Git does not own GitHub. GitHub does not own Git. Git is an open source software, and GitHub is simply GitHub just simply uses Git. What GitHub specifically is, you can sort of imagine it as a Google Drive specifically for code. So what GitHub specifically is composed of is it's composed of like a set of different repositories in which your projects are being stored. And what a specific repository specifically is a repository itself contains like the folder of like where all your code is actually being stored. Okay, so when it comes to the context of GitHub, like then it's like the reason why we want to use GitHub is because that is a server in which your code can necessarily like all come together, or like where you can easily like store your code. This becomes useful in a number of different ways. So for example, if you necessarily want to work in a team environment, if you all like basically where that code will all come together is in the context of GitHub on a single server, rather than you all always having to do things like coordinate on your local machines of like, where are we going to store the central version? That answer is like provided through GitHub specifically. Okay, I know I just went a bit fast there, but does anyone have any questions? No? Okay. So I'm going to start by demonstrating how we specifically use Git then. Okay. So I'm going to pull up the Git command terminal. So right now, like if you've never used a terminal before, that's okay. I'm going to show you a few simple like commands. So also, by the way, we're using like a terminal. We're going to just use like basics. I'm not going to show you how to use the Git GUI just because like I prefer using like the terminal. I personally think the terminal is a lot easier to use than like the desktop version of Git. But yeah, so how do we specifically use this? So a few commands, dir, which just stands for directory. This will show you all the folders that necessarily exist within a single folder. But let's say I actually want to enter a folder. So projects is where I store most of like my coding projects. So I'm just going to do cd projects. Misspelled that, sorry. CD just stands for change directory. And I do this again. And now you can see all the different folders that's contained within this single folder. So let's say I actually want to create a project. So the command for that is just mkdir, which just means make directory, and then you just enter a name. So I'm just going to call this simple Git Workshop. So here it doesn't exist before, but once I do that and I just do dir, now it exists. So here it is. I just created this folder. I'm going to now enter it. Just to show you something, let's say I accidentally enter the wrong folder. If I want to exit a folder, all you have to do is do cd change directory ... and it'll just take you out of the folder. Okay, so let's actually go into this folder. So right now it's completely empty because it's just a folder that I just made on my terminal. So I'm going to open this folder up in VS Code. By the way, if you have VS Code and you just do code dot, it'll just open up the folder in VS Code. Okay. So I'm just going to create like a few simple Python files here. So I'm going to call this hello. I'm going to also make a folder called goodbye. Not sure. Okay, there we go. Now I'm just going to write some very, very simple lines of code. I misspelled that. And then I'm just going to print here. Goodbye world. That has a dark connotation, but that's okay. Oh wow, I misspelled that too. I should have taken English in university. Okay, so so now the question then becomes, how do I move this code specifically to GitHub? So when I go to GitHub, so this is what GitHub looks like. As you can see, there's like a set of like different repositories that each contain different sets of code. So if I go into a repository here, this is a React project that like I made for a company, but basically it's like you have different like, basically it's just like, you know, you have files and like each of these files contain different sets of code. But let's say I want to actually create a repository to store the specific code I just made. So hello world, goodbye world. So all you have to do is just go to your GitHub. Oh, by the way, if you haven't made GitHub yet, I recommend you do make an account, because this is like where like you store your projects, and then this is what makes collaboration really, really easy. I'm going to specifically show you how collaboration works in a minute, but I'm just going to show you right now how you can specifically move your code to GitHub. So, okay, okay, the list of like faces is sort of blocking the new repository. Okay, I can hide that and move that. Oh, that's useful. So click new repository and you just name it something. I'll just name it like sure, I'll just go with this. You can make it public or private, doesn't matter. I'll make this public. And you can choose to initialize this with a README. I'm not going to. I'm going to show you how you can specifically add a README like within your project. So I'm going to skip this step. So then you just do create repository. Okay. So first off, let's talk about how we actually move this code towards GitHub. So the first thing you need to understand is just the idea that this is that like right now, Git doesn't know, oh wait, this is the wrong terminal. Okay, Git doesn't know that like this code that I have here, Git doesn't know this code exists. Git doesn't know that I want to move this code to GitHub. So how would I do that is I would firstly need to initialize this like folder as a GitHub repository. So you just do git init, and that initializes a Git repository. And what it creates is a folder known as .git. Now, what the .git folder does is it stores a database and as well as the history of all your past commits. So this is what makes tracking changes really, really easy in Git, because no matter what version of the code you are working with, it is all going to be contained within this folder that's always going to exist within your GitHub repository. So let's say you have someone else who's new to your team and they want to, I'll show you how to do it later, clone this repository, or they want to necessarily get a version of this code and they want to see the past changes. Well, that's very easy because every single version of that repository will contain this folder. Okay. So now let's type git status, which will tell you the status of this repository. So I want to add like specific files to GitHub, but right now Git doesn't know which files I specifically want to add. So all you have to do is you just have to do git add and then type out the files you specifically want to add. So I've added hello specifically and uniquely. So I'm just doing this to show you like why git add as a function is incredibly, incredibly important, because git add tells Git which files you specifically want to track and which files you specifically want to like add to GitHub, as well as which files you necessarily want the changes to be committed to. So I've added hello, but I did not add goodbye. So if I were to continue to commit, that would specifically mean that hello like would be the only file that was actually added to the GitHub repository. I'll do that for now. I don't need to add goodbye just yet. But how do I actually make sure Git knows that I want to specifically store or save these changes? This is why commits are specifically so important. What a commit is it's basically just taking a snapshot of like the specific changes that are made to a specific file. What that like specifically does is that like basically what this means is I'll just show you. By the way, every commit command needs a message. So I'll just say initial commit. What that does is that it basically like the message, every commit needs a message. I recommend you always have like a good message. Initial commits what like people usually use for like their very first commit. But yeah, here, once I make that commit, Git will instantly list out the changes that were necessarily made. Well, not the specific changes, but how many changes were made. So now now that I've told Git, I like, yes, these are the changes I want to save, and these are the changes I want to track. But how do I then get these changes onto GitHub specifically? How do I get these changes onto the server? So what you do is you need to push these changes. But here's a problem. I'm going to run the git push command, but this isn't going to work. And the reason why it's not going to work is because I haven't specifically specified which repository I actually want Git to push these changes to. So Git here gives a specific command for this. So I'm just going to copy this and I'm going to do git remote add origin. And this will specifically add a URL. So then Git knows where the changes, where the changes are going to be pushed to. So I'm just going to add that. And there we go. And if you want to check what the remote URL is, you can just do that. And it's the one we want. Great. Okay. So now I'm just going to do git push. This still isn't going to work. And the reason why is because I haven't specifically specified which branch I want this code to be pushed to. I'm going to talk more about why branches are uniquely important, but just know for now that you need to tell Git not only which repository you want to push the code to, but also which branch within that repository you want to push these changes to. So I'm just going to do git push, and that'll specifically tell Git I want these changes to be made to the master branch. The master branch is the main branch, or basically the main version of the code or the project that you're specifically working on. So now I've made this change. Okay, so now let's say I want more people to actually work on this project with me. How do I then use this as a mechanism for collaboration? So here's what you do. So what's really, really important to note is that this being a distributed system is incredibly advantageous. And the reason why it's advantageous is because there's no centralized version of this code that exists. That is to say that basically, let's say someone adds a feature, they necessarily do something incorrect, or they accidentally add a mistake. That's fine, because since there are other versions out there that exist, what that necessarily means is that there's still a version that exists that is totally functional, and that that feature doesn't affect the whole version of the project at large. So this is specifically the master branch. So the importance of this being the master branch and creating other branches is that, so basically what a branch is that a branch is specifically a copy of your project. So when you create a branch, the reason why that's uniquely important is because that means that you can make changes to your code without affecting the main version. So if you do things like want to add a new feature, for instance, but you don't want that new feature to necessarily go live until that feature is actually done, that's why branches become incredibly, incredibly important. So I'm going to talk about branch structure quickly here. So basically, when you create a branch, it copies the code over from the branch that you copied it off of. And once you finish that branch, all you got to do is you just simply merge it back to the master branch. Okay, so how do we do this? How do we create a branch and then merge it back to the original branch? And how do we create these new features? So I'm going to first commit so I'm going to first commit the file I didn't commit yet. And then I'm going to show you specifically how to make this new branch, how to make changes that don't affect the original branch, and how to merge those changes back. So, okay. So to create a branch, so you just type the command git branch, and then you just type the name of the branch that you necessarily want to create. So let's say I want to create a new branch. I'm going to call this branch, I don't know, new branch. So then you just type the command git branch, and this command shows you which branch you're on, as well as it lists all the branches that exist locally. But this branch exists locally. So what that means is that if you go here, so we've committed goodbye, but Git doesn't specifically know that this branch specifically exists because we created this branch locally, but we also need to ensure that this branch exists remotely. So in order for it to exist on our remote repository, we have to push this branch onto Git in the same way we would push our changes. Now, we don't want to specifically commit this branch because committing is you necessarily want to save your changes. All we are doing is we're simply pushing a branch onto our remote repository. So all we have to do is do git push origin new branch. So I apologize, by the way, my Wi-Fi is pretty bad these days. Well, it's been acting bad these days. So if any of my commands show kind of slowly. It's probably because of my Wi-Fi. But okay, so now that I've pushed this branch, now Git knows that another branch necessarily exists. So, okay. So let's say I want to make changes to this branch. So let's say I just want to make changes. I'm going to define a function, do math. I'm going to quickly define like a couple of like variables and just do very simple math with these variables. So I'm going to print x plus y, print x minus y. Okay, and then I'm just going to call this function. Oh, by the way, I should probably run this as well. Okay, there we go. So I've made these specific changes, and right now I'm on. Oh, okay. So also another thing to note is that it's really important that you know which branch you are on. So right now I'm on the master branch, but let's say I want to make changes to new branch. All you have to do is just do the command git checkout and then just the branch name. So git checkout new branch. Okay. So now I'm going to push these changes onto Git, and I'm going to show you what happens. So just git add, git commit, added math, git push origin new branch. Okay, so basically the only thing to know about branches is that when you're on that branch and you want to push branches, like push the changes to that specific branch, just make sure with like your git push command, you're just specifying the name of the specific branch you want to push to. Okay, so now these changes have been made. And if we go to goodbye, now that function that we've made that like specifically does math has been added. In contrast, however, on the master branch, these changes do not exist yet. So this is why it's extraordinarily advantageous to use different branches, because what this specifically means is that, let's say you have one person that's trying to add a feature on new branch. Let's say you had another branch called, I don't know, branch 3 or something, or branch 2. It's like you have like these different set of branches in which you have people doing different things. And then when when all those features are done, you can just simply like really easily merge these changes back to the master branch. I'm going to show you how to do that right now. So I'm going to create what's known as a pull request. A pull request, what that basically is that when your code is ready to merge, you create a pull request. And what that basically does is that it basically lets you look at the changes before you actually want them to be made to the master branch. So you create a pull request. And yep, this branch has no conflicts. I'm going to show you like what it means to have a conflict and how to specifically fix it later. But right now we can just simply confirm the merge. And that's that. So now if we look at the master branch, the changes have been made. What I'm going to do right now is I'm going to delete the branch that I just made, because it's really good practice to, once you're done with a branch, to specifically delete it insofar as like you no longer need it. Like you don't want to have any branches that are necessarily like inactive, because like that's just really bad practice. Okay, so I'm just going to go to this. I'm going to delete this branch. Okay, so I've deleted new branch. Now I've deleted it remotely. I also have to delete it locally. So how do I do that? So it's a very simple command. You just have to do git branch and then like -d new branch. So, oh, extra H. Okay, cannot delete new branch. Oh, okay, it's because I'm on the branch. So you have to specifically check out of this branch. You have to move to a different branch. Okay, so then this is fine, by the way, since it's not fully merged, since we have a version that is fully merged. So I can just simply run this command and delete this specific branch. So, okay, so now the branch I'm on is master. Let's say I want to make changes to this. So let's say I want to do print, I don't know, hello there. Okay, so what I'm going to specifically show you now is why it's incredibly important to make sure your repository is always like updated. So, okay, when I'm going to make this change, I'm going to show you right now, it's not going to work. So this change isn't going to work because because like if you imagine like basically our diagram here, it's like our master branch like in the remote repository is like basically there have been more changes made to the master branch on our remote repository than there has been on our local repository. So since those branches no longer share a history, you can't merge it back, which is why you have to make sure that your local branch is updated as possible. This is where we get into the idea of like pulling and fetching. So what a git pull does is it basically merges the changes from the remote branch to the local branch. So basically, let's say I made a change like hello there here. If I did a git fetch, it would basically this line would just be deleted because it would overwrite any changes I made and just create an exact replica of the code that like is on the remote repository. If I do a git pull, on the other hand, it'll simply merge those changes here. So I'm going to do git pull. And okay. And now since I've done git pull, so now it's like all this code that was on my remote repository has been updated here. Let's say I do git push, or like I try to do git push again. It works. Okay. So far what I've just taught you, what I've just told you is like, how to make changes and like specifically how to make changes in the context of a team. Other things I'm going to show, however, like all of this, like broadly speaking, presumes that those changes like are always going to work out. So now I'm going to show you like what happens if those changes don't work out. So for example, I'm going to create a new branch right now. Actually, you know what? I'll make a new branch right now. Okay. I'm going to make a new branch. I'm going to call it new branch 2. I'm going to check out to that branch. I'm going to push that branch. And now I'm going to make a lot of changes to this branch. I'm going to, let's say I move this function, I move it like above goodbye world. Let's say I change these values to like say, I don't know, 10 and then like 40. And then let's say I just like do a lot of weird things with this code. I'll just like garble it around. And then I'll even add like a main method here. I'm just coding this really, really badly, by the way, because I want to show you specifically what happens when like these sort of like merge conflicts happen. So I'm really trying to confuse Git. So for main, I'm just going to type here. Oh no. Okay. I'm just going to call the main method, and then I'm just going to commit these changes. So I'm just going to add okay. Made these changes to this branch. Now we're just going to do things like try to make a pull request, right? Okay. I didn't actually, okay, you know what? I'm going to, fuck this. I'm going to try to confuse this even more. I'm going to, okay. I'm going to need to try to confuse this even more. So I'm going to do a bunch of import statements, import random, import math. I'm going to commit these changes, and then I'm going to, okay. So I'm going to, once I confuse it, I'm going to merge like these changes back to master branch. And I'm going to try to confuse this like as much as I possibly can just to show you something cool. Okay, just gotta go to my repository. I'm going to compare and pull requests. Able to merge. Okay, I'm going to merge this. Okay, that's been merged. So now I'm going to do like a lot of weird things. So I'm going to do this. This is really bad practice, by the way. I recommend you don't like, make sure your import statements are always at the top. This is just what I'm doing is really bad practice just to show you something. So I'm going to add what I just changed. I'm going to commit these changes. And now I'm going to try to, so I push these changes to the repository. Now I'm going to try to make a pull request. Yeah, okay. Okay, my code is too simple to try to confuse it. How can I try to confuse this even more? Okay. Print, okay. I'm going to have to try to confuse this like even more. Let's say I have, okay. Wait, Mingda, do you have any ideas on how to create a merge conflict?
How to force a merge conflict here?
Yeah.
Okay, it's like if you have two branches, basically.
Yeah. No, because it's like you want to have conflicting pieces of code, right? But I think it's like the code I have here is like too simple to try to force a merge conflict. That's
Yeah,
the
because
problem.
they can be like discrete statements. Try adding an if statement. That usually makes things really complicated. As soon as you have indentation and tabs, it basically ruins people's lives.
Okay. Uh, okay. I'll do if x plus y equals, I don't know, 32, return false. And then I'll just do, I don't know, do math, and then I'll do print, do math. Okay. And then, so if I push these changes, and then if it's like, yeah, okay. Git add.
This should cause a merge conflict unless Git's like gotten really smart recently.
Yeah, unless. Okay, git commit. Git push origin. Okay, and then I'll just like change this to like 132, and then like hopefully this will work. Oh wait, no, I need to merge the branch first. So I'll make the pull request, create pull requests.
Yeah, this usually comes in with the more complex projects. With something as simple as this
Yeah.
demo, you can figure everything out properly. But when you're like David writing like stuff with like hundreds of thousands of lines of code, it gets quite complicated very quickly, and you have to deal with merge conflicts, and those really are some of the worst things you can deal with when working with this.
It happens a lot with like package.json too. It's like if your libraries aren't updated, but you also like constantly update your libraries on a different branch, it's like they don't know which library to use. Okay, so wait, I'm just gonna check master. I'm just gonna check. Okay. Now, hopefully this will work. So, okay. Git add.
I think you need a bit more than that to force a merge conflict.
Okay. What other things could I screw with this with?
Try modifying your other. Let's see. It usually works with like the actual indented code inside the statement. So like to have a block inside there. I don't know what else you could add really. See, I'm trying to think of like what my merge conflicts look like, and they're often exactly the same, like the same shape and form. It's just
What if
that
I added indented things like if, but like I just do it for like the sake of it. It's like, okay. And then I'll like just commit that and like see how it goes. Okay, wait, git add, git.
okay. Let's see if we can merge these.
Okay. Uh, wow, it's able to merge. Yeah, okay.
You kidding? Okay.
How do we,
How do you create a merge conflict? That's a really
it's
good
like
question.
when, you know what? Okay. But like, okay. I'm trying to see like,
Hold on, I got you something. Um,
okay, what if I did a couple of functions? So if I did that, and then what if I also did like def to RNG, and then like I did like import random, and then I'll do return random dot rand int 1 to 6, and then I'll just call that here, and then do RNG. This isn't going to print anything, but like, or I could make it print something, and then
I sent you a live repo I found on GitHub. I think that does a pretty good job at making.
sorry, on GitHub.
Yeah, there's somebody wrote up a shell script of what it looks like. I I don't know if that might be of help, but
Sure, where do you send it?
it sort of like forces it. It sends you on Discord. It sort of does it like manually, so it may not be the best demo. So just keep going with what you have right now.
Okay. I'm thinking like if I can like make like a really like fucked up functions, it's like, and then like change something to these functions. So if I do like a function here, and then it's like, I don't know, I'll commit this and okay, I'll just try to do this and see if it works. Git add. So this should be able to merge, I think. Okay, this should be able to merge, but then it's like, if I like do something really fucked up with these functions, it's like, maybe that'll,
Maybe I'll do something with it.
yeah,
Oh yeah, this one's able to merge just fine.
okay.
And Git's like good at this.
Okay, but like, I guess like you can see like here, it's like Git's actually really good at like just simply like taking all your changes and like combining it together. But like in the event like it doesn't happen, it's like you have to when it like say like here, it's like it'll either say like able to merge or like unable to merge. And if it's unable to merge, you have to like specifically go through like your code and like specifically like try to like figure out like where you want your code to like fit in and where in order to make it all come together. In terms of like trying to create a merge conflicts.
It is a bit difficult to do with simple code, but like it's sort of like you can think of it as let's say somehow now you're running Google Docs, like you are now Google, okay, and like but instead of being able to use computers, they hired you as like an unpaid intern to basically put everyone's changes onto a document. Okay, two people on the document basically highlight the same paragraph and replace the paragraph with two different lines of text. So let's say the first paragraph is like, it's just a sentence like, an apple fell into the ground and I ate it. And then the first person says, okay, a blueberry fell into the ground and then ate it. Another person says a pineapple fell into the ground and then I ate it. And then you're like, okay. You both of you guys said this at the same time, and you both started off the same base branch, which was an apple fell on the ground and I ate it. But then you have the blueberry person, the pineapple person, and then you have no idea which one is correct. So you say, okay, I have a conflict here. I need someone to resolve this so I can merge the changes through. But see, if the way that the changes were done was such that they changed different parts of the sentence, it would actually be all right. If changing apple to pineapple would work, and instead of say fell onto the ground, you could say fell into the ocean, and that would merge just fine. But the merge conflict sort of arises from cases like that. And what we mean by people editing at the same time is sort of like basically trying to put things on the same commit, and it gets rather messy sometimes.
Okay, I tried to change the function's name, see if that works. Go to this branch, create. Wait, really? It can over. Wow. Okay. Git's gotten really good then, because I remember when we were doing like package.json, it's like
it happens a lot, doesn't it? I think this is more a problem when you have multiple people working on a project as well.
Yeah.
When people code with like a lot of different things. Anyways.
Okay. I'm going to try to see if I can force a merge conflict, but like, does anyone have any questions like with what I just went through? Okay. Let's see what other fucked up things I could do to this. Okay, what if
well, we do have to move on to the next workshop in 10 minutes. So
yeah, no, it's fine. We can end it here then.
Awesome. All right.
I can like try to find like I can like try to like figure this out and then like do a recorded example.
Yeah, that would work. Awesome.
All right. We'll end it here. Thanks for coming, I guess.
Yeah, if there's any more questions, feel free to ask them in the Discord and approach either David or I. We'd be more than happy to answer your questions. We'll sign off for now. See you at the Discord bot workshop.